In class exercise 3, chapter 14, problem F14.7. If the contact surface between the 20 kilogram block and the ground surface is smooth, determine the power of the force F when time t is 4 seconds. Initially, the block is at rest. This is an interesting problem because we need to apply the concept of power and efficiency and equations of motion that we have studied in chapter 13 and kinematics that we have studied in chapter 12. So all three concepts are being applied in this problem. Now, there are a couple of keywords in the problem definition, such as the contact is smooth, means this contact is smooth. What it means that do not consider friction. And the initially block is at rest, that means initial kinetic energy is 0. So let's draw a free body diagram to start with. So block has weight, mass 20 kilograms, so it's 20 times 9.81 Newton, that is the weight of the block. Because it is resting on the ground, there is normal force N, and then there is this applied force F. Out of this total value of 30, only 4/5 of 30 is responsible for the horizontal motion of the block, while 3/5, because the block slides in the horizontal direction, block does not move in the vertical direction, so only this component of the force is useful, while 3/5 of 30 Newton is not useful for any displacement of the box or the block here. Okay, so let's apply the first equations of motion in Cartesian coordinate system, that sum of forces in x direction is equal to mass times x acceleration. We can only, so this is our free body diagram. We can also draw corresponding kinetic diagram such as this MAX. That's the kinetic diagram. Yeah, so this force is 34/5. That's the force which is acting in the horizontal direction, and that's equal to mass time ax. Ax is the x acceleration. So this is x-axis, this is y-axis. So ax is the x acceleration of the block. So we can calculate ax as 1.2 meter per second square. Okay. Now velocity, we can apply this equation, kinematics equation, that final velocity v2 is equal to initial velocity plus acceleration times acceleration multiplied by time. So this equation is nothing but v equal to v0 plus at. We have studied this in chapter 12. I have just used 2 and 1 to define the condition of the block after this force is applied and before the force is applied. Initial velocity is 0, acceleration is 1.2, and time is 4 seconds here. So it's multiplied by 4 seconds, and that's v2. So velocity of the block after 4 seconds is 4.8 meter per second. And now the power of the force P is equal to F times Fx times V2, where Fx is the x component of the force, which is 30 multiplied by 4/5 multiplied by V2, which is 4.8. So this is 115.2. If we round it to three significant figures, this is 116 Newton meter second, or joule second, or watt. Okay, so that's how we have solved the problem. So let's look at it one more time. So we have drawn a free body diagram. For this problem, we have drawn a kinetic diagram. We applied the equations of motion from chapter 13. We applied kinematics from chapter 12, and then we applied power efficiency or power force and velocity equation from chapter 14. Okay, and then calculated the final power. Problem in class exercise 3, problem number 2, 14.42. In this problem, the Jeep has a weight of 2,500 pounds and an engine which transmits the power of 100 horsepower to all the wheels. Assuming that the wheels do not slip on the ground, determine the angle theta of the largest incline the Jeep can climb at constant speed of 30 feet per second. it will make more sense if we simplify and draw a free body diagram for the jeep. So let's draw it here. So this is the incline. This angle is theta. And we draw jeep by a block, just simplifying it for now. Now the jeep, when the engine of the jeep drives all the four wheels, these wheels they rotate in clockwise direction. However, when they come in contact with the ground applies the force in the opposite direction. So F is the force which is coming from the ground onto the jeep, which is responsible for the vertically upward motion. So that's the F, or you can call this traction force coming from the ground. So that's the force F. And the weight of the jeep given here is W, and there is the weight. Actually, if you draw a line which is perpendicular to this incline, then this angle is theta. So this angle and this angle, they are the same, where this line is perpendicular to incline. So W has two components, W cosine theta, which is this component, and that acts in this direction towards the ground, and W sine theta, which acts in the opposite direction of this F. Okay, or in other words, you can say that this F is actually same as W sine theta in this particular example, because the key word here is the constant speed. So what is the acceleration of a jeep when the speed is constant? So acceleration of jeep is change in velocity speed divided by time, and since this is constant, there is no change here. Acceleration is 0. So we can set up our coordinate system. X-axis parallel to incline and y-axis perpendicular to incline. So yeah, we can define our x and y axis here as the coordinate system, x and y. So there is no x acceleration of the jeep, that is 0. So it's time to calculate the variable. So W is 2500 pound. Now we need mass in our equation. So mass is 2500 divided by 32.2 slug. Power of the jeep is given as 100 horsepower. Now the units are given in FPS system, so we need to convert this into FPS. So 100 multiplied by 550 is the conversion factor, foot pound per second. So one horsepower HP is equal to 550 foot pound per second. So we have multiplied 100 with that, and we get the power of the jeep here, okay, which is 55 and then 3 zeros, foot pound per second. Speed of the jeep given as 30 feet per second. Now we can apply the equation of motion. Sum of forces along x direction is equal to mass times x acceleration of the jeep. Now x acceleration is nothing but the acceleration of the jeep parallel to the incline, and that is 0. So this is 0. What it means that there are two forces along the x-axis. W sine theta, which is in the negative of x-axis, and F, which is in the positive direction instead of x-axis. So this is F minus W sine theta is 0. Therefore, F is W sine theta. Okay. And we will make use of this equation in the final formula for power. So power is equal to F dot product V, or F multiplication V. Now this power is 55,000 that we have here is equal to F, it's this W sine theta, and V is given as 30. Okay? We have been given V as 30 here. So everything we know in this equation except theta. We know the weight of the jeep, which is 2500 pound, sine theta multiplied by 30. So it's 2500 multiplied by sine theta multiplied by 30 equals 55,000. So P equal to F multiplication V. See, we are not using cosine theta here because the force that we have defined is actually parallel to the displacement. So there is no use of this angle here, like F and V are in the same direction. Okay, so when we solve this equation, we get sine theta as 0.733. So theta is sine inverse of 0.733, or arc sine and that is 47.16 degrees. Okay, so that's our final answer using power efficiency equation. Okay, so the steps are: define the coordinate system, calculate the acceleration parallel to the surface, which is 0 because the speed is constant. We draw a free body diagram and then apply equations of motion along x direction. Get the value of f in terms of w sine theta, and then apply the power equation and substitute value of f and calculate theta.